Okay, so we're going to talk about angles greater than 360, but first we'll just remember this about when you are finding an angle on the XY plane. So if you want negative 310, that means you're going to go clockwise. Your initial side of your angle is where you are at 0 degrees here on the x-axis. We call that the initial side. Is where you start to create your angle. And then you go clockwise all the way around 90, 180, 270, and then you're going to go a little bit more to get to 310. Now 270, 310 minus 270 is going to be 40. So you're going 40 more degrees to get to your terminal side where you're ending up. But you never work with that angle, the angle between your terminal side and the y-axis. You only ever work with the angle between your terminal side and the x-axis. So that is 50 because this is a right angle. The first quadrant is a right angle. So if that's 40, this would have to be 50 to make up 90. All right, if you were going to go positive 220 degrees, again, your initial side is 0 degrees. That's where you start. You're going to go counterclockwise because it's positive. You'll go 90, 180, and then a little bit more, 40 degrees more to get to 220. And that is the angle you will use because it's between the x-axis and the terminal side. If you go the other way to get to that same place, you would start at 0 and go counterclockwise. You'd go clockwise, 90, and then another 50 degrees. So you already know that, but just kind of shoring that up. All right, so if you have an angle that is greater than 360, if you were going to go to 410 degrees and you started at your initial side, the positive side of the x-axis, you would go 90, 180, 270, 360, and another 50 degrees. That angle, 410, we would say it is coterminal with the angle 50 degrees because if you go 50 degrees from 0, you end up here. And if you go 410 degrees from 0, you end up here. So if two angles, whatever they are, end up in the same exact place, we would say those angles are coterminal. All right. If you wanted to go negative 770 degrees, again, you're going to start at 0 degrees and you're going to go 90, 180, 270, 360, and then you're going to go a whole nother 360, which is going to bring you to 720, and then you're going to go 50 more to get to 770, which again, this time it's coterminal with negative 50 degrees, which we could also call 310 degrees. So there are an infinite number of ways to describe how to get to a certain place on the unit circle. We're going to use the unit circle to help us find some sums of trig functions. So cosine 135. All right, that is right here. Cosine is your x coordinate, and that is negative square root of 2 over 2. And then tangent 330. Here we are at 330. Tangent is y over x, so negative 1/2 over square root of 3 over 2, which is just negative 1 over the square root of 3. Now, you never leave a radical in the denominator. So when we're done with this, there better not be any radicals in the denominator. So negative square root of 2 over 2 plus, we're going to multiply this by square root of 3 over square root of 3. So we have negative square root of 3 over 3. We'll get a common denominator, which is 6. So negative 3 square root of 2 plus negative 2 square root of 3 over 6. All right, now we have cosine negative 60 plus cosine 210. All right, we're going to start at 0, and we're going to go clockwise 60 degrees. So that's 30, 60. Puts us right here. Cosine is your x coordinate, so that's 1/2. Cosine 210. Now you're going to go counterclockwise because it's positive. 210, 90, 180, and another 30 puts you at 210. And we're talking about cosine, so it is the x-coordinate on your unit circle. So that's negative square root of 3 over 2. So we could write this 1 minus the square root of 3 over 2. All right, we have cosine 570 plus sine negative 765. All right, so to go 570 degrees, we can go around the circle one time. So we'll go all the way around, puts us at 360. And then to figure out how much further we need to go, we could subtract 570 minus 360, just in case you can't do that in your head like me. You're going to go another 210 degrees. So you go all the way around the circle, get back to 0, and now you're going to go another 90, 180, and then another 30 to get you to 210. So it's the cosine, which is the x-coordinate, so negative square root of 3 over 2, plus now sine 765. Now 2 spins around the circle is 720. So I'm going to spin around the circle 2 times, and then I'm going to have to go another 45. This time we're going clockwise because it's negative. So 360, 360, that puts me at 720 right here. And I'm going to go another 45 degrees. Going to put me right there. So I'm looking for the sine. That's the y-coordinate. So negative square root of 2 over 2. So that's negative square root of 3 minus the square root of 2 over 2. All right, now we're going to look at boat in the river problems. You've done these in Algebra 2, but we're just going to do them again. These are problems where you're talking about uniform motion, rate times time equals distance, except now your rate is made up of 2 rates. If you're flying against the wind, your rate is going to be the rate of the plane minus the rate of the wind. That's pushing it backwards. If you are flying in the direction of the wind, then you add the wind speed to your rate of your airplane to get the actual rate you are going. If you're in the river, boat in the river, if you're going down the river, that means the current of the river is pushing you along. Going down is easy. So it's the rate of the boat plus the current. If you're going upriver, the current is pushing against you, and therefore you have to subtract the rate of the current from the rate of the boat. All right, so let's look at an example. One day Selby found that her plane could fly 5 times the speed of the wind. She flew 396 miles downwind in a half hour more than it took her to fly 132 miles upwind. What was the speed of her plane in still air, and what was the speed of the wind? Your book uses subscripted variables for this. I like to just line everything up like a table. Rate times time equals distance. So upwind and downwind. All right, when you're flying upwind, that means you're flying against the wind. So you've got the rate of the airplane minus the rate of the wind for your rate. When you're going downwind, you are flying with the wind. So the wind is pushing you. And so your airplane plus the rate of the wind is going to be your rate. All right, so let's see what information they give us. She found that her plane could fly at 5 times the speed of the wind. So we can put this somewhere else. The airplane's speed is equal to 5 times the rate of the wind. She flew 396 miles downwind, and that took her a half hour more than it took her to fly 132 miles upwind. So I'm going to put 132 for the distance upwind. And then for the times, it says that when she was going downwind, it took her a half hour more than the trip upwind. If we call the upwind time T, we can call the downwind time T plus 1/2. We know that the speed of the airplane is 5 times the wind, so we can go ahead and change these A's up here to 5W. So the rate upwind is actually 4W. 5W minus W, that's 4W. And the rate downwind is 6W. So I can now write two equations in two unknowns. So 4W times T is equal to 132, right? Times time equals distance. 6W times T plus 1/2 is 396. So these are my two equations. If I go ahead and use the distributive property on the second one, I'll have 6WT plus 3W equals 396. I know that 4WT is 132, so I'm going to solve for WT by dividing by 4. So that's going to give me 33 for WT, which I'm going to put in right there. So 6 times 33 plus 3W is 396. If you multiply 6 times 33 and subtract that from 396, you get 198. So 3W equals 198. If you divide by 3 on both sides, you get that W is equal to 66 miles per hour. So the speed of the wind is 66 miles per hour, and we know that A is equal to 5 times that, and so that is 330 miles per hour for the airplane. So airplane, 330 miles per hour, and the wind, 66 miles per hour.